Pulse modulation. So here now seeing about pulse modulation. So it is a method of transmitting a digital pulses between source and destination in a communication system through a wired or wireless medium. That is the channel. Wired or wireless medium is nothing but it's the channel. In a communication system, basically we can transmit the messages from source to destination through channel. That time here transmitting digital pulses between source and destination in a communication system through a wired or wireless medium. It is a digital signal can be a discrete level. Digital pulses are binary form. So it is also known as a pulse communication system. So here the definition of pulse modulation is nothing but the carrier is no longer a signal but consists of a pulse strain and some parameters varied in accordance with the instantaneous values of the modulating signal. In this here parameter is nothing but amplitude, position or width. This is the parameter. This parameter can be changes in accordance with the modulating signal. And then the types of pulse modulation. Here pulse modulation is classified into two types, that is analog pulse modulation and digital pulse modulation. Analog pulse modulation is nothing but it is a continuous signal. Here it can be classified into two types, that is the PAM and PTM. So PTM is again classified into two types, that is pulse width modulation and PPM. PPM is nothing but pulse position modulation. And then digital pulse modulation can be classified into four types, that is PCM. That is PCM is nothing but pulse code modulation. DM is the delta modulation and ADM is adaptive delta modulation and DPCM is the digital pulse code modulation. These are the types of pulse modulation. Next one, the definition of analog pulse modulation is nothing but here the carrier wave is a periodic pulse chain and some of the characteristics of carrier pulse may be amplitude or position or width is varied in accordance with the instantaneous values of modulating signal. So here this is the analog pulse modulation. So analog is nothing but a continuous signal. So this also consists of two types, PAM, PTM. So PTM again classified into two types, that is pulse width modulation and PPM. Next one, digital pulse modulation. So it is also defined as a transmitting a digital form of a sequence of code pulse and then modulating signal in a discrete in both amplitude and time. So it consists of four types, PCM, TM, ADM and DPCM. Next one, the merits of digital transmission. So it is a secure communication and more immunity to noise than analog signal. So compared to analog signal, it is more immunity to noise and easily multiplies. These are the merits of digital transmission. Mostly digital transmission can be used for secure communication. For it is also used in military purpose. And the demerits of digital transmission is nothing but it a high complexity and larger bandwidth and also synchronization is must in all digital systems. So these are the advantages and disadvantages of digital transmission compared to analog transmission. And the next one, concept of low pass sampling theorem. So low pass sampling is nothing but it can be used to converting a continuous time signal to discrete time signal. That is, it is can be used to convert analog to digital. So in this here the process of converting a continuous time signal x of t into discrete time signal x of n. This is the block diagram of that is the sampling process waveform. So here this is the envelope of sampling signal. So this EM and EC is the bandwidth of the signal, continuous signal. So it can be sampling process. Next one, statement of sampling theorem. So it states that if the highest frequency is contained in a continuous time signal is Fm and the signal is sampled at a sampling rate Fs. So the condition is Fs greater than or equal to 2Fm. Then the continuous time signal can be exactly recovered from the samples. So in this Fs is a sampling frequency and Fm is a highest modulating frequency. In the statement, the sampling theorem consists of two conditions. What is the two conditions means? One, Fs less than 2Fm means the spectrum interfered with each other, that is called aliasing effect. So when condition Fs less than 2Fm means the aliasing effect can be occurred. Aliasing effect is nothing but the spectrum interfered with each other. This is the two spectrum interfere with each other, it makes the aliasing effect. That how can We prevent the aliasing effect means we can use the low pass filter can be used to limit the band of frequency of the signal to FM Hz. This can be used to prevent the aliasing effect. So the sampling frequency effect should be selected with the condition of Fs greater than or equal to 2 FM. Next condition, when Fs less greater than 2 FM means the spectrum does not interfere with each other. This is the spectrum. The two spectrum does not interfere with each other, so there is no aliasing effect is occurred. This is the two condition of sampling theorem. Next one, Nyquist rate. So it can be defined as the sampling rate is exactly equal to 2 FM samples per second at a bandwidth FM. So it is given by Fs equal to 2 FM samples per second. This is the Nyquist rate. And Nyquist interval means it can be defined as time interval between any two adjacent samples, and sampling rate is Nyquist rate. So it is given by Ts is equal to 1 by 2 FM second. This is the Nyquist rate and sampling theorem.